You know your major organs, right? Heart, lungs, brain, and you're probably pretty familiar with your digestive system too.
Uh-huh. The big players.
Exactly. But there's this quiet, kind of unsung hero working behind the scenes. It's absolutely vital for your daily health.
Hmm. Okay, I think I know where you're going with this.
It's constantly preventing you from like swelling up, fighting off invaders, even helping digest fats, yet it barely gets the credit it deserves.
Definitely overlooked.
So today, we're diving deep into the lymphatic system, our mission, to pull out the really important stuff from some fascinating sources, classic biology, recent research, to figure out what you need to know about this silent workhorse.
It sounds good. It's a fascinating system.
And get ready for some aha moments. Like, what if I told you it's crucial in fighting cancer, helps digest fats, and we only just found parts of it in your brain?
That last one still blows my mind, honestly. Major discovery.
Okay, let's unpack this. Most of us get the circulatory system right. Blood pumping, closed loop, all that.
Yeah, the basic.
But there's this whole other network quietly keeping us healthy. And it's absolutely essential for immune function.
Exactly. That's the lymphatic system or lymphoid system. It's an organ system in vertebrates like us, part of the immune system, and really complementary to the circulatory system.
Complementary.
Think of it as this huge network. You've got lymphatic vessels, lymph nodes, lymphoid organs, tissue, and the fluid itself, lymph.
So it's kind of like the circulatory system's less famous cousin?
That's a pretty good way to put it.
Oh.
But there's a critical difference.
Oh, yeah. What's that?
The circulatory system is closed. Blood stays in the vessels. The lymphatic system, it's open.
Open? How does that work?
Well, think about fluid balance. Your circulatory system filters maybe 20 liters of blood plasma every day through capillaries.
20 liters? Wow.
Yeah. Now, about 17 liters get reabsorbed right back into the blood vessels.
Okay.
That leaves about 3 liters behind in the interstitial fluid, the space around your cells.
Right. So what happens to those 3 liters?
That's where the lymphatic system comes in. It's the accessory return route. It collects that surplus 3 liters and gets it back into the blood.
So basically, it stops us from swelling up like balloons every single day.
Exactly. It's a critical function you probably never even think about.
Until it goes wrong, I guess.
Precisely. And that fluid it carries, lymph, it's pretty similar to blood plasma, actually.
Is it?
Yeah, it's basically interstitial fluid once it gets into the lymphatic vessels. It's got waste products, cell debris, bacteria, proteins, and importantly, lots of lymphocytes, immune cells.
Lymphocytes. So that's the immune connection.
That's a big part of it. And the name lymph even comes from the Latin lympha, meaning water. Fits its fluid role, right?
Makes sense. Okay, this is fascinating. But how does this fluid actually move? You said there's no heart for the lymphatic system.
Right. No central pump like the blood has. It's a different kind of engineering challenge.
So how does it work then? Gravity.
Not exactly gravity, though that plays a tiny role maybe. It starts with these really thin-walled vessels, the lymph capillaries. They're blind-ended like tiny little cul-de-sacs in your tissues.
Okay.
And just soak up that interstitial fluid. Then they merge into larger collecting vessels.
But still no pump.
Still no pump in humans. The main drivers are muscle contractions.
Like just moving around?
Exactly. Breathing, the pulsing of nearby arteries, and especially your skeletal muscles squeezing those vessels. That's what pushes the lymph along. Some other vertebrates actually have lymph hearts, but we rely on movement.
Interesting.
And crucially, these vessels have tons of one-way valves, like little gates.
To stop it flowing backwards?
Precisely. There's a primary and secondary valve system ensuring it only flows in one direction. No reflux.
So staying active literally helps your lymphatic system pump itself. Another reason to get moving.
Absolutely. Movement is key for good lymph flow. These collecting vessels then merge into bigger lymph ducts.
Ducts, like pipes.
Yeah, essentially. There's the right lymphatic duct that drains the upper right part of your body, and then the much larger thoracic duct, which handles the whole left side and the lower body.
Okay, got it.
And both of these big ducts eventually dump the filtered lymph back into your bloodstream, right at the subclavian veins near your collarbones.
So it all makes its way back to the main circulation. Wow.
It's a pretty elegant hidden highway system relying on just our daily movements.
Incredible. Okay, so it's handling fluid, but you mentioned the immune part is huge. Where does that happen? Where do the immune cells do their thing?
Right. That's where the lymphoid organs and tissues come in. We usually divide them into primary and secondary.
Primary and secondary, okay.
The primary lymphoid organs. These are where your lymphocytes, those specialized immune cells, are actually generated from immature precursors. Think of them as the factories and the basic training camps.
Factories and boot camps. I like that.
So first up is the bone marrow. That's your main lymphocyte factory. It creates T-cell precursors, sort of the raw recruits, and it handles the full production and maturation of B cells, the antibody makers.
Okay, bone marrow makes the cells. Then what?
Then those T-cell precursors travel to the thymus. That's the T-cell boot camp.
Thymus? Where's that?
It's located kind of between your lower neck and upper chest. That's where T-cells mature and learn to tell the difference between foreign invaders and your own body tissues. Super important.
So they get educated there.
Exactly. It's most active when you're young, and it shrinks after puberty, but it keeps working to some extent. Losing your thymus leads to really severe immunodeficiency.
Wow. Okay, so born in the marrow, trained in the thymus. Fascinating.
It really is. Then, once they're mature, these cells move to the secondary lymphoid organs.
And what happens there? More training?
Not training, more like
Here.
deployment and activation sites.
Yeah.
These are the strategic meeting points where the mature, ready-to-fight lymphocytes hang out, waiting.
Waiting for trouble.
Basically, yeah. This is where your body initiates an adaptive immune response. That means it encounters a specific foreign invader, an antigen, and mounts a custom defense against it.
Tailor-made defense.
Exactly. Things like clonal selection, making lots of copies of the best cell for the job, and affinity maturation, where they actually fine-tune their response to be even more effective.
Okay, so what are these secondary organs?
The most well-known are the lymph nodes, little bean-shaped structures.
Ah, the swollen glands you feel when you're sick.
That's them. They're organized collections of lymphoid tissue that act like filters for the lymph fluid. You've got hundreds, maybe close to 800 all over, lots in the head, neck, armpits, groin.
Strategic locations.
Right, where they can easily sample fluid from areas likely to encounter pathogens. When they swell up, it's because those follicles inside are expanding as they react to antigens.
Makes sense. What else?
Then there's the spleen. You can think of it like a very large, complex lymph node, but it filters blood, not lymph.
Okay, spleen filters blood. What does it do immune-wise?
A lot. It produces immune cells, clears out old red blood cells, that's the red pulp, but the white pulp synthesizes antibodies. And get this, it stores maybe up to a quarter of your body's lymphocytes ready to go.
A reservoir.
Exactly. And it holds monocytes too, which are another type of immune cell that rushes out to help repair tissues after injury. It's like an immune hub and emergency depot.
It's amazing how these seemingly small organs are doing so much heavy lifting, constantly on guard.
They really are. And then there's another category which is pretty interesting, tertiary lymphoid organs, or TLOs.
Tertiary, what are those?
These are actually abnormal, sort of lymph node-like structures. They don't normally exist. They form in tissues at sites of chronic inflammation.
Chronic inflammation, like from what?
Could be long-term infections, organ transplant rejection, autoimmune diseases, and even in some cancers.
Wait, they form in cancers? That sounds odd. Is that good or bad if they show up near a tumor?
That's the fascinating part. It's often a good sign. These TLOs can play a key role in the immune response against the cancer. Yeah, they can act like little immune outposts right at the tumor site.
Yeah.
Patients who have TLOs, especially active ones, often have a better prognosis, particularly with immunotherapy treatments.
Huh. So the body tries to build its own little lymph node right where it's needed.
Sort of, yeah. It shows the immune system trying to adapt and fight locally. It makes you wonder what else the body does that we don't fully understand yet.
Definitely. Okay, any other lymphoid tissues we should know about?
Well, there's also widespread tissue like molt mucosa-associated lymphoid tissue found in your gut lining, respiratory tract, places like that. Guards the entry points.
Makes sense.
But the really big news, relatively speaking, was the discovery of functional meningeal lymphatic vessels.
Well, meningeal. Like in the membranes around the brain.
Exactly. Lining the dural sinuses in the central nervous system.
It's the brain.
Hold on. Lymphatic vessels in the brain. I thought the brain was considered like immune privileged, separate from all this.
That was the dogma for decades, that the brain lacked a direct connection to the lymphatic system. This feels like a massive deal. When did this happen?
It was groundbreaking work by Jonathan Kipnis and Antoine Louveau at the University of Virginia School of Medicine, published in 2015.
Just 2015, wow.
Yeah, it literally redrew the map of the lymphatic system, completely changed our understanding.
So what does that mean for brain diseases?
Huge implications.
Yeah.
It opens up whole new ways of thinking about neuroinflammatory diseases like MS and neurodegenerative diseases like Alzheimer's. Suggests the brain's immune environment is much more connected to the body's overall immune system than we ever thought.
Mind blown. Okay, so immune powerhouse, fluid regulator, brain connection. What else? You mentioned something about digestion after a big meal.
Ah, yes. Another surprising role, fat absorption.
Fats, how does that work?
So in your small intestine, you have these specialized lymphatic vessels called lacteals.
Lacteals, okay.
Now, most nutrients, carbs, proteins, they get absorbed and go straight to the liver through the portal vein for processing.
Right, standard procedure.
But fats, lipids, they take a different route. They get packaged up into these little particles called chylomicrons.
Like little fat taxis.
Uh-huh, yeah, kind of like that. These chylomicrons are too big to get into the blood capillaries easily. So instead, they get absorbed into the lacteals, into the lymphatic system.
Ah, so the lymphatics pick them up.
Exactly. This fat-rich lymph fluid is called chyle. It looks kind of milky. This chyle travels up through the lymphatic system, mainly via that big thoracic duct we mentioned, and it gets dumped directly into the bloodstream via the subclavian vein. Notice what it missed.
It didn't go to the liver first.
Exactly.
Yeah.
It bypasses the liver's first-pass metabolism. It's a unique shortcut just for fats, getting them into circulation more directly.
So the next time I have a pizza, my lymphatic system is working overtime on the fat transport.
Pretty much. It's handling that special delivery, bypassing the usual liver checkpoint. Quite an intricate design.
It really is. Okay, so this system is doing all this vital work. But what happens when it, falters, when things go wrong? What does that mean for health?
Yeah, that brings us to the clinical side, which is obviously really important. And one of the big connections is, unfortunately, with cancer and metastasis.
Metastasis, the spread of cancer.
Right. Because the lymphatic vessels are everywhere, they can become highways for cancer cells to travel from a primary tumor to other parts of the body.
Oh, man.
The lymph nodes act as filters, and they can trap these cancer cells. Sometimes they destroy them, which is good. But if they can't, the node itself can become a site for a secondary tumor.
So checking the lymph nodes is crucial in cancer staging.
Absolutely. Understanding the lymphatic drainage pattern from a tumor is critical for diagnosis, prognosis, planning treatment, the works.
And aren't there cancers of the lymphatic system itself?
Yes, exactly. That's lymphoma, cancer that arises directly from the lymphatic tissue, usually classified as Hodgkin or non-Hodgkin lymphoma. They're related to lymphoid leukemias too, basically tumors of the same cell types.
That's a really tough connection. The system meant to protect us can also spread disease.
It's a double-edged sword, unfortunately. Another common issue people might notice is enlarged lymph nodes, lymphadenopathy.
The swollen glands again.
Right. Often it's just reactive. Your nodes are doing their job, fighting a local infection or inflammation. That's normal.
Okay. But sometimes it's more serious.
If you have lots of nodes swollen in different areas, generalized lymphadenopathy that can signal something systemic, widespread infections like mono, TB, HIV, or autoimmune diseases like lupus or rheumatoid arthritis, or, again, cancers, either lymphoma or metastatic cancer.
So swollen nodes need checking out if they stick around.
Definitely worth getting checked. And then there's lymphedema.
Lymphedema, that's the swelling, right?
Yes, it's swelling caused by lymph fluid backing up because the system is damaged or malformed. It can't drain properly.
Where does that usually happen?
Most often in the limbs, arms, or legs. But it can affect the face, neck, abdomen too. If it gets really severe and chronic, it can lead to elephantiasis.
Elephantiasis, that sounds extreme.
It is. The skin gets really thick and hard, kind of like an elephant's hide. It's often caused by parasitic infections like lymphatic filariasis, common in some tropical regions.
Wow. What else causes lymphedema?
Surgery is a common cause, unfortunately, especially removing lymph nodes, say in the armpit during breast cancer surgery. That disrupts the drainage pathways.
Right. So what can be done about it?
Treatments often involve things like manual lymphatic drainage, specialized massage technique, and compression garments to help move the fluid. And there's some hope on the horizon with new drugs in clinical trials, like Lymphactin and Ubenimex.
Okay, good to know there are options and ongoing research. But it sounds like a really intricate system to even look at.
Yeah.
How do doctors diagnose these problems? Can they actually see the lymphatic system?
That used to be really difficult. But modern imaging techniques have made huge strides.
Like what?
Well, there's something called dynamic contrast enhanced magnetic resonance lymphangiogram, DCMRL for short. It uses MRI with a contrast agent to get really high-resolution images. Great for diagnosis and planning surgeries.
Okay, MRI-based. Anything else?
Yeah, there's also near-infrared fluorescence imaging, NIRF. They inject a special dye into cyanine green and use a camera that can see a glow under near-infrared light.
Whoa.
It lets you see the superficial lymphatic vessels and how the lymph is flowing in real time. It's really revolutionized how we assess lymphatic function and problems.
Amazing. It's wild how much we've learned, especially recently. But it sounds like it took humanity a long time to even figure out the basics of this system.
Oh, absolutely. The history is quite a journey full of misunderstandings and debates.
Let's take a quick trip back. Who first noticed this stuff?
Well, Hippocrates, way back in the 5th century BC, mentioned lymph nodes. Later, Herophilus and Galen in ancient Greece and Rome saw the lacteals, those fat-absorbing vessels in the intestine.
But they didn't quite get it right.
No, they thought the fluid, the chyle, went to the liver. That idea stuck for centuries.
So when did things start changing?
The real breakthroughs came in the 17th century. A bit earlier, mid-16th C, Falloppio described the lacteals again. Then in 1622, Gasparicelli clearly identified them in dogs and showed chyle wasn't carried by veins, though he still thought it went to the liver.
Still stuck on the liver idea.
Yeah. The big correction came from Jean Piquet in 1651. He discovered the thoracic duct and showed that the fluid from the lacteals actually entered the venous system through this duct, bypassing the liver initially. That finally disproved Galen.
Okay, so Peke figured out the drainage point.
Right. Then, almost simultaneously, in 1652, Olof Rudbeck in Sweden and Thomas Bartholin in Denmark independently discovered the lymphatic vessels throughout the body, not just the intestinal lacteals.
Independently, at the same time.
Yep. Led to a pretty bitter fight over who discovered it first. Bartholin ended up naming them lymphatic vessels. Later on, Alexander Monroe gave a more detailed description of how the whole system functioned.
So lots of scientific drama and slow realization over centuries. And then fast forward quite a bit, and we find this completely new piece in the brain just, what, 9 years ago?
Isn't that incredible? After centuries of mapping this system, this huge component in the central nervous system was hiding in plain sight until 2015.
It really puts things in perspective.
That discovery by Kipnis and Louveau, it wasn't just adding a detail. It fundamentally changed a core belief about brain immunity. It's a powerful reminder that there's still so much we don't know, even about our own bodies.
Wow, what a deep dive that was. The lymphatic system, I mean, from being the body's fluid recycler to immune defense HQ, a fat transport highway, and now even a player in the brain. It's truly blown my mind today.
It really is an unsung hero. We've seen how vital it is for just maintaining fluid balance day to day, how it filters waste and trains our immune cells, that surprising role in absorbing fats, and yeah, those critical links to major diseases like cancer and lymphedema.
It's far more central and complex than I ever imagined.
And the fact that huge discoveries like the brain lymphatics are still happening, it just underscores how much more there probably is to learn about this incredible network inside us.
Absolutely. What an intricate, dynamic system, still revealing its secrets. So maybe the next time you feel a bit sluggish or you notice a swollen gland, just take a moment to appreciate this amazing, ancient, yet still kind of mysterious network working tirelessly inside you. It makes you wonder, what other hidden systems are still waiting to be fully understood? And what could those discoveries unlock for our health in the future?